Today we'll be looking at two different methods of calculating GCSE and A Level titration calculation. This calculation is part of the quantitative curriculum at GCSE and it quite often is tested in A Level as well. I'm going to show you two different methods of doing the calculation. One is a traditional method, and then the second one is a method that I normally teach my students to make sure they don't miss any steps and secure full marks. So in this exam question, we're going to have a look at what's been given to us already. And if we start looking, you have been given 25 cm cube of HCl. You've been given 0.1 mole per dm cube of NaOH. And you also have 12.1 cm cube volume, and what we need to find out is a concentration, which we don't know, of the acid. So if you was to look at the traditional way of doing this, is you will write a balance equation, and if we write down sodium hydroxide, which is aqueous, reacts with hydrochloric acid, which is also an aqueous, makes sodium chloride plus water. So that's your balanced equation, and you will see the ratios of everything is 1 to 1. So 1 mole of this to 1 mole of that, and the ratios are really important, and you will see why when I do my further steps in the calculation. The next thing we're going to do is calculate the number of moles. Of sodium hydroxide, and we know that we have been given 25 cm cube for the acid, so we're going to leave that at the minute. In the meantime, we are going to change the volume, which is 12.1, into dm cube. So if we change 12.1 cm cube into dm cube, then you need to divide by 1000. That will give you 0.012 dm cube. So that's your volume being changed into right units. And you know the concentration already. So if you look at the formula, number of moles is concentration times volume. So we know we changed the volume already. If we times by concentration, which is 0.100 moles per dm cube, that should give us our number of moles for sodium hydroxide, which is 1.21 times 10 to the minus 3 moles. So you now have figured out the number of moles. Now, like I said right at the start, the ratio is 1 to 1, which then means I can assume that the number of moles for HCl is also 1.21 times 10 to the minus 3 moles. If I do that, then this time we're going to look at number of moles. I should write down moles for HCl. We're going to assume it's also 1.21 times 10 to the minus 3 moles. And if I was to calculate the concentration, then I'm going to rearrange the formula, and then to get the calculation, I'm just going to do 1.21 times 10 to the minus 3 moles divided by, we were told 25.0 cm cube. Change that into dm cube, becomes 0.025 dm cube, and then the answer is 0.0484 moles per dm cube. So that's how you would do it traditionally. For this question, I'm going to show you a totally different method of doing titration calculations. It's a tabulated method, so you draw a table. This way you don't miss any values or get confused when there's too much going on or working out. students find this much more easier, and it's quite clear on what needs working and what's been given to you. So look at the question. A student carried out titration to find out 25 cm cube. That's the volume of 0.500 moles per dm cube. Concentration of HCl neutralizes 35.35 of NaOH, so another volume there. And we're looking at the concentration of NaOH. So let's do the conversions first to get them all in the right units. So if I do 25 divided by 1000 to get into dm cube, that'll give me 0.025 dm cube. And I want to change 35 to divided by 1000, give me 0.035 dm cube. So everything is now in dm, and the two things I need to work out is NaOH and HCl, and then we're just going to write down everything we know. So we're going to do the concentration, going to look at the volume, look at the number of moles, ratios, and so on, and then the final concentration. So first of all, we need to look at what we know a lot about. So we know if we was to look at the HCl, that the concentration is 0.500 moles per dm cube, because they have told us that already. The volume was, they're giving us 0.025 dm cube. We just did a conversion of 25 cm cube, and if you to look at number of moles, it's concentration times volume. So I'm going to do 0.500 times 0.025. That'll give me the number of moles, which is 0.0125. The ratio of them is 1 to 1 if we did the balance equation in the last question. So I can assume that this is also 0.0125. I've been told the volume of NaOH is 0.035 dm cube. And if you was to rearrange your formula, then to get the concentration, I need to do number of moles divided by volume, which is basically 0.0125 divided by 0.035, and that gives me an answer of, if I to write it down here, let's bring it down here, the concentration is equal to 0.36 moles per dm cube. You may find this much easier way to do it, because you can see what's been given out to you and what you need changing, and then you can fill in what the gaps are. I hope this helps. Don't forget to subscribe.